Hey, good day, everyone. Welcome to yet another SANS SEC 503 live stream. I am Nik Alleyne, and I will be running this session for today. As always, just in case you did not get to see any of the sessions before, I am Nik Alleyne, currently a director at Serious Computer Solutions, where I work specifically within the Managed Security Services unit. Along with that, I've authored 2 books, Hack and Detect, as well as Mastering TShark Network Forensics. I also blog at securitynik.com. I have a GitHub page where everything that we have discussed between session 1, 2, and the one we will discuss today, you can get all of the pcaps here. And most importantly, I'm a SANS SEC 503 instructor, and today a lot of the content we will be discussing relates to packets, basically the things that we discuss in the SEC 503 class. Stephen is also going to drop some links in the chat shortly, basically some references. Welcome, SK. Yeah, basically some references, and we will talk about those shortly. But without further ado, and as always, these sessions are, for the want of a better word, action-packed. So let's get right into it. Today, we will look at exporting suspicious and malicious content from pcap files. We will look at this from different perspectives. We will look at it from the perspective of TShark knowing that there's a file in there that it can export. And then we will look at it also from the perspective where TShark does not know. So we have to find creative ways to ultimately be able to export that content. Okay. Thanks, LinkedIn user. So let's get going. And once again, this is related a lot to the SEC 503 class, and we will talk more about that shortly. But for starters, let's say when we spoke on the first session, we were the newbie on the team, and the senior cybersecurity guys and gals brought us some challenges. They wanted us to prove some hypotheses from the perspective of threat hunting. We addressed those from the network layer as well as the transport layer. Today, we're looking at more specifically application-related tasks. So they brought us a couple of pcap files, and the first one they want us to look at is a file called, let's say, cap infos, and it's called security Nik files. Remember, whenever you get a pcap file, one of the first things you should do is take advantage of the tool called cap infos. Just to get some insights into the packet, the duration when this packet capture occurred, as well as maybe the encapsulation, and all of these information that is ultimately going to prove beneficial to you. Welcome, Lucio from Lisbon. James, welcome. All right, so now that we have that, we need to be able to prove whether or not there's a malicious file in here. Remember, when we start off, these files are more than likely going to be suspicious. So let's figure out now what is going on here. First up, let's say we take TShark, right? Let me clear the screen. If I look at the help for TShark, pipe this into more, we can see here, let's come down. We have an option here that says export objects. So we can literally export objects from the pcap file. And how we do that is to take advantage of the protocol we want to export from, and we specify the destination directory where we would like to save the file. So for this first one, let's clear the screen, and let's say TShark, let's say export objects, and let's look at the help. This is going to help us to understand which protocols are available for us to extract from, okay? Welcome, Jude. Welcome, LinkedIn user. So we can see here a number of different protocols, but the ones you and I more than likely will deal with on most days, HTTP, which we're constantly on the internet, as well as SMB. So we will take advantage of those 2 protocols immediately. So first up, let's do HTTP. Now, let's say we are aware that there is a file in here or something that we need to download. One of the first things or the second thing we should do once we get that pcap file is look at the statistics. So I will say -n, -r, and we'll say security Nik files, right? Let me say, remember, if you don't know what the -z is, for example, we can go back to one of the previous sessions. But what I'm looking for here is the statistics. I will say -q. I don't want the packets to flow by, just show me the statistics information. And here I will say IO, show me the protocol hierarchy. And as I look here, I can see immediately on the HTTP, there's an image. How do I know it's an image? Well, it says image as well as it says JFIF. How does TShark know that this is an image? Well, if we go to the link that Stephen provided, right, for Gary Kessler's website, and we come down here and we say, let's say we run a search for JFIF. JFIF. We can see here that, for example, a JPEG file has a header, right? A few bytes that are called, let's say, the magic, if you want, the file magic, or basically the header, right? So by looking at these headers, and you will get more understanding of this shortly, but by looking at these headers, you get greater insights into the type of file you might be dealing with. Welcome, James. So from TShark perspective, let's just quickly export this file here. But before we do, what can we determine about this file? Let's say we want to figure out maybe the host that this file was downloaded from. Let's say extract some fields. Remember, if you don't know what these are, we discussed these in the previous sessions. Let's say we want to look at the HTTP requests, specifically the method. Right? Along with that, we want to see the host that this traffic is being downloaded from. And finally, let's see what is the file, basically the path and the file name. So we'll say http.requests.uri. And if I run this here, it seems like nothing is there right now. But if I sort, let's say unique, I can just leave it sort. Right? We can see here we have get, which would be the method. Let's clear the screen here. Let's put unique in here. We have get, which was the method, right? This is associated with the request method. We have the host, which means this is where the file was downloaded from. And ultimately, we have the entire URI. But what we need is only the file that was being downloaded. So now if I tell TShark, I say, hey, let's say export, sorry, that's an up arrow for simplicity. And remember, we have to specify the protocol and the destination where we would like it to go. So the protocol we would like to export from at this time is HTTP. And where would we like to export it? To the temp folder. Okay. I'll say -q also. Sorry. TShark, sorry. Let's go here. So I made a mistake there previously in that I did not specify a file. And because I did not specify a file, TShark tried to capture the packets live. I did not wish for it to do that. I wish for it to read back from a pcap file. So we will tell it now export objects from the HTTP protocol and save that file in the temp directory. Okay? Now, if I clear the screen again and I do ls on temp, remember the file that we just learned about previously was named Kitro Falls JPEG. So now we have that file. We can conform that by saying, let's say file, temp, Kitro Falls JPEG. We can see that this is an image and we can now open it. Temp. Okay. And we now have an image that was extracted. This is the Kitro Falls. It is said to be the longest single drop falls in Guyana in South America. So what did we do there? We just extracted content, or what we consider as suspicious content, from a pcap file. Now, for simplicity, I could have, instead of opening that file, remember we believe it might be suspicious. So instead of opening that file, I might have wanted to run an antivirus on it. For example, maybe clam AV, right? And I can say verbose, and I can specify the file. And this would run the antivirus on it, and this would help us to understand whether or not this was something that, you know, we should be concerned about. It might be suspicious, but the antivirus might come back and say that, no, it is not malicious, right? At least not from the AV's perspective. Okay, so while that's running, the next one we will look at is similarly, similar to how we extracted content from HTTP, we will look at SMB. Why? Because in the previous example, we extracted one file. Okay? We will also see that we have the ability to extract multiple files at one time, which means that we don't necessarily have to drill down and select a particular file. But along with that, we will learn other things, right? So in this example here, it says scan files 1, infected file 0. So this is only going to be considered as suspicious right now, not malicious. Thanks, Ross. Much appreciate that. Ross says he loves the book. Which one of the books, Ross? All right, so let's move on now to SMB. So we have another pcap file, and this one, let's say TShark-n-r, and the file we want to work with now is called SMB export.pcap. Okay, and I'm not going to go through the copy infos again or the protocol hierarchy. We know exactly that those are the first and the second things we should do respectively. So I'll say -q, t, fields, and -e. And what I would like to see here is SMB file name. And to keep things simple, I will pipe this into sort and move this into unique also. We press enter, we can see at this point in time, we have multiple files that have been seen within SMB. And just as how we exported those that Kaito files image in the previous session, we can do the same with this one right now. Okay? Thanks, Ross. Ross said it's the Mastering TShark book. Great hands-on experience. Thanks, much appreciated. All right, let's get back here. Okay, so what we do know is that we have various files. If we wanted to focus specifically on, for example, this file, what we can do is take advantage of something we will talk about in the next session. TShark has the ability for us to take advantage of regular expressions and so on. But for now, what I will do is say why. This means I'm specifying a display filter. And what does that display filter, or what should it be? I will say, I'm looking for smb2.filename that might contain the string PDF. And we can see here now, when I say contains PDF, we see something was returned here with .pdf, right? Basically, we have 189 here, and it seems like there might be something here in these two also with PDF. But that is not our major concern right now. We just wanted to identify a particular string. Now, we also see that there's frame 189 here. So let's focus specifically on frame 189 to try to learn a little bit more about this activity. So I will press the up arrow again, and I will change the filter now to, let's say, frame.number equal 189. Clear the screen. And this is the only frame that has been returned. Okay, so now we can drill a little deeper into that. So let's say we wanted to determine where the file was accessed from. Okay, so what I can do here, I can press here once again, taking advantage of the fields. Let's say smb2.tree, right? And we can see we have the computer where the share was accessed, or where that share is, and the share folder. This is information that you are probably using in your Windows environment on a regular basis. And remember, show me the packets. If you're doing it on the network, we can more than likely detect it. So this is an example here of you can see someone access a particular share. And if you wanted to know the specific file name that was accessed from that share, we can now say -e, and I can say smb2.filename. Now we have not only the share, right, the host computer, the share, as well as the file name we have. What else can we actually determine from here? How about the user that might have actually attempted to access that file or might have accessed that file? Let's just press here, add another field, and let's say smb2.account. We can see now that the user that accessed that file was security Nik. Okay. What about the user's domain? Let me clear the screen just to get some real estate here. And notice I'm just adding on the fields as we go along, okay? We can see now that computer was part of a work group, not necessarily a domain, but part of a work group. And there's a lot of other information we can glean from here. Let's just get one more. What is the name of the host that the person connected from? So here now we have Kali. So what can we determine from here? Let's say the user security Nik that was in the domain work group using the computer name Kali access the file hack and detect PDF from computer which share this. Just like that, from within the package, we are able to tell who and what access that share as well as access that file. Now, obviously, I used it the simplest way to be able to show you the various fields. But what we could have also done is, if I come here, I can say -v, like type this into more, and we see now we have all of this information here. And if we look in the SMB2 header, let me scroll down here, ton more information we can find. We can find information, for example, on the type of share. We already spoke about the tree ID, right? Where the share was and so on. We can see information on the account, the host, the domain, right? All of that information is readily available in the packets for us to take advantage of, right? And we ultimately have the file name. So let's just say we go back here now, right? Let's say we look for the file names, and let's take a text file because we will come back to the PDF later on. Let's say we take the file. Actually, you know what? Let's export everything. So I will clear the screen, but let me get here first. Okay, clear the screen. Now, when we exported previously, we had this pcap file. We specify export, the protocol, and the location. Let's now change the pcap file to, let's say, SMB export, right? And change the protocol from HTTP to SMB. Press enter, right? Then we do ls on temp. We can see we have all of these files that have been exported. Everything except these ones at the bottom here was basically exported, right? So the first example, we exported one file. In this one, we're exporting multiple files. There's a file. Let's see what this one here has inside, right? So I will just highlight this. I'll copy it. Let's say cat. Let me clear the screen, right? So everything is at the top. And I will pipe this into more. Sorry. This should be temp. /temp. And we can see we are able to extract content from what seemed like some type of text file with a lot of domain names inside. Whatever these domain names are for, I don't know, but we have that. We have those. Welcome, Emil. Okay. All right. So what have we done so far? We've done two things of interest. One, we've exported content from HTTP. That's a protocol that we're all using on a regular basis. And we determined that that image that we exported was, whilst it might have been suspicious, it was not reported as malicious by the antivirus. And we could do the same thing with these files that have been exported here. But in the interest of time, let's move on to something that is a little bit more interesting now. So you got yet another pcap file, right? Let's see now, we say TShark. And this file is called decoders pcap. So the team gives you this file, right? And they say, hey, we believe that there is suspicious content behind NTP. So at this point, you know, I personally have not heard about, other than like amplification attacks and so on, I have not really heard about malicious content being stored inside of NTP. Mohammed asks why it didn't download the PDF file. Actually, Mohammed, it did download the PDF file. So if we go back here and I say ls-temp, right, it would have downloaded the, look here. I'm just not using that file right now because we will talk more about that file later on. But to Mohammed's question as to why it did not download the PDF, it did. It actually extracted all of these files here. I just choose to focus on one. Hopefully that helps Mohammed. Okay, so let's go back here. So now we have this pcap file, right? And the team is telling us that malicious content is being used behind NTP. So let's say, let's clear the screen. Let's see, press the up arrow. Let's say -Q. Once again, we look at the statistics. And in this case, let's look at the protocol hierarchy. Now, when we look here, we see TCP and we see NTP. Can someone tell me what protocol NTP uses. I mean, I'm seeing TCP here, and you might say TCP, but for what I know, that's not the case. So can someone tell me what protocol NTP uses? Whilst you're doing that, let's go back here. And let's say we go to, I think we have the RFC. I think Stephen might have shared the RFC with you all. But let's say we take RFC 5905. Let's say RFC 5905. Okay. And if I open up RFC 5905 that talks about NTP, right, and I run a search for TCP, I can see it says here, it seems to have only 2 references to TCP. Let me zoom this in. And it says reliable message delivery such as TCP can actually make the delivered NTP packets less reliable. Okay, but that does not make sense for me so far, because everything I know tells me, yes, LinkedIn user, right? Everything I know so far tells me that NTP uses port 123, right? UDP 123. But when we look here, we've seen NTP. So this now obviously is some type of cause for concern. What can be going on here? Does anyone have any opinion on what might be going on here? Anyone want to take a try as to what might be going on here? Whilst we're waiting on the responses, let's say we run this again, right? And we just pipe this into more. Now, what I also know is that if we look here for NTP, for example, we've seen NTP version 1, we've seen NTP version 2, right? As we scroll through, we've seen NTP version 4. Why all of these different versions? Is it a case whereby maybe the host and the client and the server are trying to negotiate the right NTP protocol? I mean, I don't know, because for what I know, once again, NTP work, unlike LinkedIn user said, port 123, UDP 123. So let's now try to figure out this from a different perspective. Let's say we decide, hey, you know what? Rather than trying to use TShark, let's take advantage of another tool. Let's say we take advantage of strings. And we look in here and we say, show us all the packets that are not the packet, but the strings that are 10 or more bytes. And then we want to look at it from an encoding perspective, where the encoding is 7-bit ASCII. Okay? And the file I will give it is decode as, and let's pipe this into more. Wow. What does this look like? What type of communication does this look like to you? Let's take a second to see if we can answer that. And Kit also said high bytes in NTP might be some data encapsulated. Very good point, right? What type of data does this look like to you? To me, this looks like HTTP, because I'm seeing a GET, I'm seeing a file name, I'm seeing HTTP 1.1, okay? So for me, it is quite possible that somebody probably maybe ran HTTP on port 123, but TShark does not know how to decode that at present. So let's go ahead and tell TShark how it should treat this packet. Okay, so let's clear the screen. Let's run TShark again here. Okay, and what we're going to say to TShark is, hey, I need you to decode this packet for me. And here is how I need you to decode it. Wherever you see TCP.port equal 123, I would like you to decode that as HTTP. Okay, I will pipe this into more. TCP.port -d TCP.port equal 123. Okay, right? So I would like you to decode that as HTTP. And now we are seeing it says HTTP, right? We can see the GET and so on. You might be thinking at this point, I can go ahead and export the content, but that is still not going to work. You're not going to be able to get the content from the, similarly to how we were able to export it before, okay? That's right. So LinkedIn user says pulling down a PDF file. Now let's try to figure out how we can get this PDF file, right? Because remember, this user is trying to download this file. We need to get this file. We cannot export it directly from TShark because TShark doesn't understand exactly what is going on here. And this is important because on day 3, for example, of the SEC 503, we talk about situation whereby your security tools are not able to detect activity, right? For example, we have a pcap file that has an SMTP attachment that is base 64 encoded. We already know that when we look at TShark and we try to, let's say we look at the help here again. Let's say we look at the help, right? If we look at the help here, we already see that there is no SMTP protocol here, right? So that is one shortcoming, as well as the attachment that we discussed in the SEC 503. It is base 64 encoded. So that is a double whammy for TShark. So what we need to do is basically extract that file. Amir said we can add it to a file, right? Let's see how we can get this information here. So what I will do is we will need to take advantage of a couple of other tools, right? So let's say, for example, we already know that when we looked at the strings, this is a PDF file, okay? This is a PDF file. And if we go back to the website I referenced before, Gary Kessler's website, and if we do search for PDF, right, this is PDF, we can see that the PDF file has a header that represents these bytes here. So what I can do, I can copy these bytes here, right? And note, there's a trailer also, and we will talk about the trailer shortly. What we can do here now, we'll say, okay, you can use a hex editor, whatever hex editor of your choice. In this case, I will use XXD since this is thing. LinkedIn user also said export objects as SMB. We will not be able to export the objects as SMB because remember, we're looking at something that is HTTP that is running over NTP. So we will not be able to export that, but we already did a demo earlier where we exported objects from SMB. So what we can do now, we can say here, you know what? Whatever hex editor we use, I'll say XXD, and I will say XXD, and I will give it the file decode as, okay? And you can see here that this is going to have a sequence of bytes, right? So what I would like to do now is, using what we just learned from Gary Kessler's website, I would like to find this byte pattern. Is that nothing was returned? Does anyone know why nothing was returned if we look at it this way? Can anyone tell me why nothing was returned? Whilst we wait on those answers, let's look at this now from a different perspective. Now, if you look here, right, my search is looking for 25, 50, 44, 46. Along with that, right, if I now change, actually, let's look at it this way. Let me see if any answers came in. Okay. These bytes are grouped by 1. These bytes are grouped by 2. So let me just come here and say, I'll say group, let me see, I think it's group bytes or group size or something like that. Group size 1, okay? And now we can see we have a pattern that's matching. Now, for this pattern that matches, what we know is that this starts at offset AC0. So what we want is where this byte actually starts. So what we can do, say this is C0, C1, C2, C3, C4, C5, C6, C7. So what we have is 8C7 is the starting position for these headers. Remember, these bytes represents the start of the PDF header, okay? The start of the PDF header. Now, what we need is to find the trailer. Where does it end? So I will copy these bytes here, and I will come back here again, and I will run this here. All right. Once again, we have not found anything. If we look back at the top here, we can see yet another potential problem. This here is uppercase, and here we're dealing with lower cases. So we need to tell XXD to now transition to lowercase, to uppercase. Okay, so I'll say dash U. Now, we still do not find anything. Why is that so? It's quite possible that the bytes have wrapped around, which means that we need to shorten this here. John Pierce brought up a good point also about little endian. In this case, we're not worried about endianness, but very good point, John. All right. We spoke about little endian or endianness in the previous session when we discussed SMB. So what we'll do now, we'll say, okay, you know what? Let's shorten this search here. Let's make this 1 byte less. We have nothing. Let's make it 2 bytes less. Now we have a match. So it's quite possible that we've reached the end. So we need to now loop around. So what I will tell XXD, I will say, hey, not XXD, I will say grep. I'll say once you find this match within this pcap file, because I know that this is more than likely the end of this line and the content is going to be wrapped around on the next line, just show me the next line once you have the match, right? And if I know, you can see now we have, actually, let me do this here. So we now have 4F46 is actually around here. So we have the entire thing, 08252525, which represents 082525, 45, I should say, 4F46, which is here. So we have the entire thing. So what we have so far is the start, right? We know the start is at 8C7, and the end is going to be at 30. This would be 30, 301, 302. Okay? What we can do, and in the interest of space, let's clear the screen and run this command again, right? We find the first one. Let's see here. Let's come here first. This is the second match, right? This represents the end. And we need the first match. Is this it here? Okay, so what we have now, right? We have the start and we have the end. So let's do a little bit of trick here. Let's say Python, right? And we need to calculate the length of this activity, of these bytes. So what we will say is Python, and we will take the end here, which is, let's say, take this number, right? I will paste it in here. And remember, this is 30, so this is 301, and this is 302. I'm stopping at 302 because of the fact that we are dealing with, let's say, if we come back here to Gary Kessler's website, we're ending at the A in the trailer, okay? So that is why we're stopping at 302. So let's come back here now. And we will change this here to 32, okay? And we minus that from here. So this is 8C0, right? The first offset here. This is 1, 2, 3, 4, 5, 6, 7. So we need to say 8C7, okay? And I will need to make this hexadecimal. So when we minus these two, we get a value here that says that the PDF has a length, or this amount of bytes makes up this PDF, okay? So let's now take advantage of XXD again to try to extract that content. Let's say XXD, and we will say, actually, let me exit here, sorry. Clear the screen, right? I will use the same XXD that we did before, right? And I will now tell XXD, here is what I would like you to do. I would like you to start, right? Basically start as in seek at offset 0x8C7. This is where we found the header for the PDF. And I would like you to go for a length of, let's paste this here, right? This is the difference or the answer we got when we subtracted those two values. I think that's it. Is that it? Let me see. We come back here. Yes, right? I'd like you to go for this length, okay? And if we now run this on the screen, we will see that this is where it starts now at the PDF header, okay? But what I need, if I take all of this and I redirect it to a file, this is going to be a text file. So what I need XXD to do for me is to basically do this. Hey, I need you to put this content or view this content in plain. Basically, I want the raw bytes, right? And now we can see we have that byte sequence here. Once again, and I'm doing this in the interest of time, but if I put this into a file, it's going to be seen. You know what? Let's just do it, actually. Let's instead put this into a file in temp. called failed data.pdf. Okay, and if we do file temp failed data.pdf, we see this is an ASCII text file. This is not what we want. We want to be able to extract a PDF file. Okay, we want to be able to extract a PDF file. So let's continue this journey. Let's now say here, and we will remove this, right? We pipe this into more again, right? And now that we have that, we can tell XXD, hey, I would like you to use another XXD. The content that is coming into you is plain, and I would like you to revert that to binary. Let me put this on the screen so you see what this looks like actually. If I do plain, pipe it into more, you see what this looks like. If I now say plain and revert, you can see now we have what is binary information here. You can see some text and so on, right? But this is binary. So if I now go and I redirect this to file, let's say 503-1 PDF, right? And we say file temp 503-1 PDF, we can see now we have a PDF document. Now, yes, I used Python and I calculated those two values to get the length. But to be honest, I did not need to. I just needed to show you that because there are going to be times when you need to carve out a specific set of bytes. But let's go back here to the strings command, right? And if we go back here, right, we can see here, where is it? Here. It already told us the content length. So we could have just take this content length here, say copy, and clear here, right? And I come back here and I tell XXD, let's name this 5032. And let's come here and just tell XXD, the length that I need you to traverse is here, okay? And we can call this we already called it 5032. And if we do file again, right, 5032, we see this is a PDF file. Now let's open this PDF file. Looks like we might have extracted the evidence. Let's say 5032. All right, so we loaded a PDF file, but if you look here, this file looks incomplete, right? If we look here, it seems like things have dropped off, right? You can look at the image and you can see a potential problem already. What might have been the issue here? Does anyone know what might have been the issue here? Can anyone tell me what might have been the issue here, right? Why does this image look so distorted? Why does this file have so much things dropped off, right? What do you think might be the issue here? While you ponder on that, let's look at it from this perspective. In the 503 class, the SEC 503, on day one, we talk about the IP protocol. And we say that IP is responsible for two primary functions. One, addressing. The second one, fragmentation and reassembly. From the perspective of addressing, IP doesn't care about the order in which the packets are delivered. So you can see these packets can come out of order, and thus that might be an issue right here. On day two of the SEC 503, we talk about the TCP protocol, and we say that TCP transmit data in segments. Those segments also stand the possibility of coming out of order, which means they would have to be reordered or reassembled. We also talk on day 3 about protocols such as SMB that might have their data coming out of order, which means once again they have to be reassembled. Thanks, LinkedIn user, right? Packet ordering is a big concern here. So yes, we were able to extract the evidence, but if this was evidence that you needed to present to the court or you needed to present to your senior team, they will come back to you and say this is incomplete evidence. So what can we do? Now, if you were paying attention to what I said earlier, right, I spoke a lot the last couple of seconds about reassembly and so on. LinkedIn user said, my first thought, you need to reorder the data, then extract the data. Absolutely. Thanks for that. Right. Now, this is exactly what we will do. We will then now transition back. Let's minimize this here. Right. Let's now transition back to TShark. And we will say to TShark, hey, TShark, I am going to give you some packets. And when I give you those packets, I don't need you to resolve the IP address to host name. And those packets are going to come from a file. What is the name of that file? That file is named decoders.pcap. And when I give you that pcap file, or when you're reading it, don't show me the packets themselves. Instead, just show me the conversation, excuse me, just show me the conversation, specifically the TCP conversations, okay? And at this point, we see we have one conversation. What we will do here now, we'll say, okay, TShark, with that one conversation, I know that this information is stored in an array. And if I have one conversation, it means the first one is at offset 0 within that array. So I will say, TShark, I need you to now follow TCP session. I want you to rebuild that session for me. And whereas previously, actually, let's do it this way, right? Show me the session in ASCII. And we can see here now, right, the information in ASCII. But this is not what we want. What we want is for TShark instead to show us this in raw. So we have the raw bytes, but we still have a problem here, right? The raw bytes that we want more than likely start somewhere here. But we have all of these data here, or all of these bytes that we need to get rid of. So we will say, hey, TShark, thank you for the help. I think you've done a lot, but there's not much more I can do with you. I need to get help from someone else. So we will say, we'll take advantage of sed, right? And what I will do is say, hey, sed, I would like you to look at the first line and then move all the way to the 14th line. And once you get there, delete everything for me, okay? Pipe this into more. And we can see now we no longer have the lines that we had seen previously at the beginning. We now start from here. So we can now tell sed, you know what, hey, we were grateful for your help also, but at this point, we don't have more need for you. What we will do is go back to our old friend XXD. And we will tell XXD the content I'm giving you is in plain, right? And I would like you to revert that to back to the binary format like we did before. And now I would like you to save that into a file called, in the temp folder, called show me the packets PDF. Okay. Now if I go back to file command and I say temp all file PDF, we can see that except for failed data, everything else is a PDF file, right? Where show me the packets? Sorry. Oh, I put it in temp. Temp show me the packets, that PDF. Okay. So all of these files are set to be PDF, but we know that when we extracted this one, the content was not in order. So let's now see if we can get this open here. Let's say XDG open and say temp show me the packets. Now it looks like we have successfully carved out that pcap file, right? Carved out that image or that PDF file from the pcap. Okay. Abishar said that's cool. Celestine would like to know where can this be rewatched. Sans is going to post this information where you can, or post the link where you can rewatch this. But I think the same link is going to allow you to be able to rewatch it later on. But what we just did, right? We had a situation where we extracted evidence. Actually, let's step back. First, TShark didn't even know that the evidence was there. Then we extracted the evidence with XXD, but we extracted incomplete evidence. So we could see that by once again looking at this file here, for example, right? This is incomplete evidence. Then we went back and we used TShark, right? We used TShark in conjunction with sed to basically remove some lines. We then use XXD once again to extract the bytes, and thus first we actually reassemble with TShark, then we get the actual bytes in the actual order, which means we now have the full evidence to our availability, right? We can now go back to the team and say, hey, this is what you wanted. Basically, show me the packets or did not happen. All right. This file is also for what we're discussing going to be considered as suspicious, but not malicious. So we're not going to go through any other further activity with that file. But let's transition to something else now. This file is actually malicious. All right. Let me close here. Close here. In the SEC 503 class, on day 5, actually starting on day 3, I use this file called attack trace pcap. On day 3, we talk about signature-based detection, where we talk about snort. And in this pcap file, right, let me say tshark-n-r -v, and I say grep ssms.exe. In this pcap file, there is a malicious executable called or named SSMS reassembling.exe, which was retrieved via FTP. So on day 3 of the SEC 503 class, when we start, I use this file to show the importance of configuring your environment specifically, or configuring your security tools specifically for your environment. Okay, specifically for your environment. Now, with this file, I move from a situation on day 3 where Snort, with the default or with the installation that we have on the virtual machine, does not detect this activity, which means we have a false negative. So can someone tell me what is the difference between a false negative, a false positive, a true negative, and a true positive? Can someone tell me that? Once again, what is a false negative? What is a false positive? What is a true negative? What is a true positive? So on day 3, I use this file to say, okay, here is how we move from a false negative to a true positive. And when we run Snort the first time, no alerts are detected. Then we create a Snort rule and we optimize that rule where we move from 300 plus alerts to one specific alert that makes sense. Then on day 4, I reuse this file as part of Zeek, where I write a basic Zeek signature to detect this activity. And day 5, I wrap this up with some network forensics. So what we're going to be doing here is similarly to what I do on day 5 of the SEC 503 class. So we know from everything that I've told you so far that there's a malicious executable in here. So let's start off by looking at the conversations. Let's say TShark, actually, let's come up here. Let's say -q -c. Let's say conversations, TCP. We can see here now we have 1, 2, 3, 4, what looks like 5 conversations. Let's quickly step through some of these here. Okay. If I now say follow TCP ASCII 0, just to show me conversation 0, right? We can see now that this looks like an empty conversation. If you dig into this, you can probably conclude that this might have been a reconnaissance type of activity. If I look at session 1, it seems like, we have all of these ones here. This is not what I expect in an SMB packet. We've looked at SMB packets in the previous session. We have just looked at SMB packets in this session. And on day 3 of the SEC 503 class, we talk about SMB. And this is not exactly what I expect to see. So this suggests to me something like a type of buffer overflow attack or something like that. Okay? Okay, so let's see. False negative is where something bad happened, but you didn't get an alert. Absolutely. False positive is where something gets detected as malicious, but it's not. Thank you, LinkedIn user. Nicholas Claude says, false positive indicates a threat that doesn't exist. Cool. False negative, no indication for an actual threat. Absolutely. True positive indicates a threat that does exist, and true negative indicates no threat. Absolutely correct. Both of you. This is a question I ask at interviews, and be it you're in security or operations, that is something you should know by heart. Anyhow, back to this session here. So what we have so far is, this looks to me like some type of a buffer overflow attack. Okay. So now let's look at session 2. And as we look at session 2, we see what looks like some FTP type of activity. We see echo, we see open. This should have been an IP address. We see a port, and we can see this greater than sign. From what we've discussed before, we should know that the greater than sign means that a file is being created with the name of O. And then you can see and, which means once this command completes, execute the next command. We see echo user 11. We see now 2 greater than sign, which means in this first instance, this file is being created, right? In this second instance here, data is being appended instead to the file. We can see get ssms.exe, which is to download the file. Once again, the file is being appended. We see echo quit. We see FTP is launched, right? And we can see the file is being deleted quietly, okay? And we see ssms.exe is being executed. So that is session 2. Let's see if we look at session 3. Now, when we look at session 3, we see FTP information. Remember, we discussed similar things in the previous session also. We're seeing username 1 and password 1. Remember, you just saw this also here, user 1, 1, right? That is the username and the password. So this is exactly what you're seeing here, right? User 1, password 1, successfully logged in. And you can see that the file will retrieve ssms.exe. So what we are going to try to do now is figure out how to extract that file. Okay, so let's go here. And let's say we run now session 4. Okay. As we look here, we see MZ. Does anyone know what MZ stands for in this context? Can anyone tell me what MZ stands for in this context? Once we take a minute to do that, let's go back to Gary Kessler's website. And if I do a search for MZ, right, we can see MZ 4D5A basically is what is used to represent Microsoft COM, or basically COM, DLL, drivers, executables. Typically, you associate this with EXE. But these COM, DLLs, all of these things have the 4D5A header, okay? Thanks, Ankit. Thanks, Mohammed. Okay. So what this tells me is that by simply looking at this header here, this is more than likely an executable file. So what we can do here now, we need to be able to extract that executable. And we can use the same tricks that we used previously, right? We can say, hey, we can say, we looked at it in ASCII here, but what we need it in is raw. Okay? We pipe this into more. We can see now we have the raw bytes. Okay? And what we will do here, we can say, similarly to what we did before, we can say sed. We specify that we would like to move from line 1 to line 6, and then we delete those lines. Okay? Pipe this into more. We can see those lines are no longer there, right? They've been deleted. These lines basically have been deleted. Okay? Now we have another problem. If we scroll all the way to the bottom of this file here, we can see that we have a situation whereby there's going to be a line at the bottom. Okay? We need to remove this line. So we can take advantage of sed once again, and we can say sed, right? Sed, I would like you to delete the last line. Okay, and if I press enter, we will let this scroll by. We can see the last line is no longer there. And at this point, we go back to our old tricks. We say XXD, the content I'm giving you is in plain. I would like you to revert it to binary, and I would like you to save that as a file called named ssms.exe in the temp folder. Okay, and if we run file on temp ssms.exe, we can see now that we have extracted our 32-bit Windows executable. Now, remember, the previous instances we were talking about suspicious file. This case, we're talking about a malicious file. So we already run the file command on it. At this point in time, you can do some additional static malware analysis, maybe take advantage of something like exif tool, right, to say temp ssms.exe, get some insights on the executable, right? You might decide that, you know what, I would like to instead do MD5 sum temp, right? And you might choose to instead take that hash and now plug it into virus total. We used ClamAV earlier, so I am not going to use ClamAV again. So we will try something different, okay? Let's instead, some of you might have heard about sysinternal tools. So if I come here and I go to, for example, let's see, live sysinternals, right? You can download the individual tools as you wish from live.sysinternals. You have this link also, okay? And the tool we will use from this group here is one named SigCheck. Okay, we will use SigCheck 64. Okay, I already downloaded that file and I'm going to run it from my Linux device. I know you're probably thinking, but sysinternal suite of tools runs on Windows, so there's no way you might be able to run this on Linux. We will also be taking advantage of Wine, for example, to run this. Okay, so what I will do is say, let me switch to the temp folder. ls.ssms.exe. We have this file here. I will say Wine. I would like you to use the tool, security Nik, I say TShark series. And the tool I would like you to use is SigCheck. Okay? And for this here, I would like you to show me all the extended information, show me the file hashes, and most importantly, show me information from virus total on this file. What is the file I'm talking about? The file name is ssms.exe. Okay? At this point in time, if everything goes according to plan, we should now see that virus total detection, we have 66 out of 75 engines consider this file as malicious. So Whereas, we might have looked at the first file and it returned 0 matches when we use clam AV. In this instance, we took advantage of VirusTotal via SigCheck, and we were able to figure out that this file was found or is considered malicious by 66 out of 75 of the virus detection engines. Okay, let's wrap this up now. At this point in time, you might decide, you know what? Okay, maybe I can do some quick, some additional static malware analysis. Maybe you say ssms.exe, and then you say, for example, you want to look at everything. Show me, for example, strings that are larger than 12 bytes. Maybe you're concerned about the encoding. Let's say 7-bit ASCII, pipe this into more. And we can see now some of the libraries that are being used. And you can now go to Microsoft website, for example, drop these here into the website and see exactly what, how these are used and, what the program might be doing. Or you can now transition this to doing some malware analysis like they do in the 4, 6, 10 class. Okay, so what did we achieve today? We looked at various scenarios. We looked at scenarios where we were able to extract from the HTTP protocol because TShark knew that there was content in the HTTP protocol. We looked at examples where we were able to extract a number of files from SMB, right? From a particular session, we extracted all of those files, and we also learned how we can detect the username that accessed the resource, the host of the computer, or the computer name that they use, their domain. We did not look per se to the computer that was being targeted because we discussed that last week. But we also looked at the computer as well as the share from which the file was accessed. Then we transitioned to the situation where TShark just does not know that there's malicious content in there, or better yet, suspicious content in the case of the PDF file, right? What TShark did was decoded the packet or attempted to decode the packet as NTP, but it was actually HTTP that was being run on port 123 TCP rather than on port 80. So TShark did not know that. So what happened? TShark assumed it was NTP, but we used XXD in conjunction with TShark to extract the evidence. And remember, those packets initially came in unassembled, right? Or not properly reassembled, which means we had incomplete evidence. But once we took TShark and we say follow the stream, we were able to get the full contents, reassemble everything, and now we have the full PDF file. And finally, we looked at a malicious executable as we do on day 5 of the SEC5. Actually, day 3, 4, and 5, I used that file as part of my demos just to build up on everything. But we saw how we were able to extract malicious executables, once again, from within TShark, even though TShark did not know that that executable existed within that file. Can you share the hash for the malware you pulled down from the pcap? No problem. I can definitely do that. Just give me 1 second. In the meantime, if you have any questions, feel free to ask. All right, let's do this here. Let's come here. The hash you're concerned about, I will give you all of these here. So Stephen, would you mind posting this for me? So you will have all the hashes there. Stephen will post those shortly. Can you share the hash from my report? Okay, that's been sent. No problem, LinkedIn user. Hey, you know what? We have just about a minute or so to go, but hopefully you enjoyed today's session on how we are able to extract content from pcap, whether that is suspicious or malicious, whether it's fully reassembled or not, how we were able to rebuild that session and get the evidence that matters, okay? Thanks, Celestine, all right? I did not get to look at all of the comments, but definitely want to thank you all for hanging out with us today. If you have any questions, feel free to hit me up on LinkedIn. Definitely will be able to try to answer as much of your questions there. Don't be shy in terms of reaching out, but feel free to go back to look at it. And my recommendation is you practice this content. Thanks, Alexis. Practice this content because if you are able to go through these sessions here and we do get the opportunity to hang out with you in the SEC 503 class, you can guarantee that this is going to be very, very much easier for you to make the most out of the class. Okay? Thanks, Israel. Thanks, Nicholas. All right. Stephen, thank you for this session today. Hope everyone had fun, and we will see you the next time.